Hello, everyone. Thank you very much for joining the today's session. My name is Sarbani Maiti. I am working as AVP AIML Cloud Service in Magic Finzer. Today's topic is how to build a production-ready machine learning system in cloud. Let's look at the high-level machine learning lifecycle stages. Data collection, data cleaning, feature engineering, train model, evaluate model, model tuning, model selection, deploy. But they are not the end of machine learning system or machine learning development. Once we go through all the life cycle stages, we need to deploy the model in production. There are various challenges we generally face in production in terms of seamless integration with existing IT and business applications, successful adoption of the consumer services, ROI target, complicated infrastructure, and high maintenance. This is an example of high-level machine learning system in production. Yes, it looks complicated. If we look at the top level, I have put together 4 different groups: data engineer, data scientist, ML engineer, data analyst. Data engineers, they do handle the data, everything about data. Data collection, data extraction, data ingestion, data preparations, data versioning, and the final trained data is sent to the model development phase where model is trained with the clean data. Data scientists are the core group of this entire system. They take care of end-to-end model development, model optimizations, algorithm, and how to create the best fit model, model evaluations, and finally they deliver the model. ML engineers are responsible for end-to-end orchestration, managing all the tools and technologies required to maintain this ecosystem. They are basically a software engineer, but with a good amount of knowledge with different open source tools and technologies, and sometimes they are coming from the full stack development background as well. Now, ML engineers may not be expert in model development, but they do have a good knowledge of model and how the model works as well. Data analysts are the people who are interested in data visualization. They work on various data analytics tools like Databricks, QuickSight, Power BI, Tableau, etc. These tools may be implemented within the system, or that can be outside the system. Somehow it is integrated with the main ML predictive analysis system. In the data science workspace, we have 3 major modules: data preparation module, model development, and model serving. Model serving can be either online prediction or batch prediction. I mean, we can say online serving or batch scoring. This is called the inference pipeline. In the model development phase, we go through the various stage of model training, model tuning, and we also need to store the feature so that that can be used by various groups. It can be offline feature store, it can be online feature store. We also record the different versions of the model in the model registry so that we can achieve a end-to-end data lineage for audit and traceability purpose. Sometimes training can be done real time as well. With all this different requirement in place, we need an end-to-end platform which comes under MLOps. MLOps something like DevOps plus machine learning development. So this is the term we are calling here MLOps, or model in production. Here we talk about various tools and technologies. Sometimes they are open sources or the entire model is deployed in cloud. In today's sessions, I'm going to talk about the cloud-based machine learning system. When I deploy a model in production, we need to consider several key factors. Let's talk about availability. A model is deployed in production. After that, the availability of the ML system is critical for the business. Onboarding the right kind of tools and technologies which are easy to adopt and can be deployed following the change management policy of the organizations. We need to maintain the reusability. We need to track, monitor, alert, and create a feedback loop, which are other important aspects of the model in production. ML system must support automatic scaling in production. When the workload increases, auto scaling dynamically adjusts the number of instances, horizontal scaling, or they can vertically increase the infrastructure configuration. When the workload decreases, auto scaling remove the unnecessary instances or they decrease the configuration from the existing system. That way we can maintain the cost. The model has to be compliant as per the regulatory requirement of that particular industry. We need to create and secure and compliant environment with the least privileged access to the sensitive data. Data at rest, data at motion must be protected and encrypted. Audit and trace activity in the production environment. Reproduce result in your environment by tracking the lineage of ML artifacts throughout the life cycle and using source and version control tools. Second important aspect is the building a trustworthy model. Responsible AI is a practice of ensuring that AI benefits society and does not reinforce unfair bias. So we can think of explainable AI as an umbrella concept which include accountability, fairness and equity, explainability, safety and security, data privacy, social and environmental impact. When a model is developed, the first stage is the problem formation or building the problem statement. Starting from there to the model deployment, there can be the several questions raised by different stakeholders. Is an algorithm an ethical solution to the problem? Is the training data representative of different groups? Are there biases in labels or features? Do fairness constraints need to be included in the objective function? Has the model been evaluated? Is the model deployed on a populations for which it was trained? Does the model encourage feedback loops that can produce increasingly unfair outcomes? All the questions can be answered by developing a responsible AI system. If we look at the three major cloud providers, AWS, Azure, and Google Cloud, they are offering an extensive advanced ML services which are providing all the aspect what I was talking about. Today, I'm going to adopt an AWS SageMaker platform to show you and demo where I'll talk about how SageMaker is helping us to build a ML system in production quickly and easily. Different considerations when we build a model in production: data, size of the data, type, data sources, amount of data, how to label the data. Then we are concerned about the choice of algorithm, problem to be solved, deep learning or ML learning, machine learning, complexity of the system, complexity of the implementation, how to manage the implementation or endpoint to serve the final consumer applications. Then we talk about the resources, which is most important. Resources in terms of the people who are working in the system, as well as resources of the means the infrastructure, CPU, GPU, how to balance the cost, complexity, and the performance of the system. Then time to production. When a model is started in the experimental phases, the final value will be achieved when it goes to the market. Time to market must be reduced in order to increase the ROI. Amazon SageMaker is a purpose-built machine learning system which is offering a broad varieties of capabilities. In the data preparation phase, they have the ground truth for the data labeling. Data Wrangler is used for data preparation, data cleaning in a visual interface. SageMaker processing, feature store. Feature store are used to store the feature. It can be offline and online feature store, which can be used across the ML lifecycle, even outside the ML project. SageMaker Clarify is used to detect the bias in the pre-train and post-train data, and Clarify also use a very famous SHAP algorithm to create an explainable AI model. In the building phase, we are using SageMaker Studio. We can use the various aspects of the SageMaker Studio, what I'm going to show you in a minute. Then train and tune. Everything can be done within SageMaker. And finally, we can deploy the model in SageMaker endpoint. Compute and network isolation is done through the VPC. Authentication authorization is done by using the key management system as well as the Amazon IAM framework. Artifact management is done through model registry. Data encryption can be done by using Amazon managed encryption services. Traceability, auditability, then model monitoring are done through the CloudWatch. This is an excellent tool where we can monitor all the logs, all the various kind of activities which are being performed inside the system. And explainability, interpretability can be achieved by using AWS SageMaker Clarify. In SageMaker, there are various ways we can build the model. The SageMaker model, we can use the custom build model. You can see the TensorFlow, Keras, PyTorch, Spark, Scikit-learn, Hugging Face, MXNet. All the custom build models are available in SageMaker framework. SageMaker also offering pre-trained models. When we have a huge amount of data, we don't need to waste our time to train them from the beginning. We can use some pre-trained model which is kind of giving a similar kind of output as per our use case. We can use the deployed version via API call. We can deploy directly, or we can fine tune the pre-trained model with our data and we can get the benefit out of it. There is another offering that is the AutoML. This is an automatic end-to-end cycle of applying machine learning to a problem. This is kind of no-code platform. If someone is new in ML system or an experienced practitioner, doesn't matter. If we don't want to spend time in coding, we can start our experiment and deployment through AutoML. It saves time, it saves the experimentation time. Cost can vary depending on the use case. How to open the SageMaker Studio? There are various ways we can open the SageMaker Studio. I'll show you in a demo. When we open the SageMaker Studio, there are, as we are talking about, various pre-built model are already available, like XGBoost, then regression and K-means and LightGBM. These models can be used in our notebook directly on the SageMaker. There are several built-in algorithms are available, starting from classification. We can see the linear learner, XGBoost, KNN, computer vision, topic modeling, recommendation, forecasting, regression, then text processing, document processing, clustering, anomaly detection, sequence translation, and many more. How to start coding? We can start our own script in our local environment, and then the script can be deployed in SageMaker by deep learning container. And the container is registered under Amazon Elastic Container Registry, which is called ECR. Once the container is registered, that can take the advantage of entire SageMaker cluster. SageMaker is a fully managed machine learning platform, so we will get benefit of all the cloud related offerings here in one place. In the script mode, we use the script locally, but we are using the SageMaker environment here. This is a sample code. We can use the train.py, and this is a sample code from a TensorFlow model, but it can vary depending on the model. Now, high level workflow. Now here we are using our own container. So let's say we have developed the script in our local project folder, and we have our own dependency, and we want to host the entire project environment to SageMaker just to deploy the model using SageMaker endpoint. This is possible by using the bring your own container model. Here we can deploy our container in SageMaker by using a Docker build, and the container is again registered in ECR. After that, SageMaker use its endpoint deployment process to deploy the model in SageMaker endpoint. In all the cases, we generally use Amazon Storage Service S3, where we where we store our intermediate files, model registry, model artifact, code artifact, and all the data, final train test data, and final data processing data as well. So S3 is a major storage which is used in this entire system. There are other storage, but right now I'm focusing on S3 only. Okay, so let's look at a quick demo where we are going to show you what all offerings are available in on Amazon SageMaker. I'm going to show you my AWS account. So here exactly is my AWS console. This is the Amazon SageMaker. If I open the SageMaker console here, this will give me two options. One is the studio, then another is that notebook. We can use the notebook instance. We can create our own instance and we can start using it. Here, I have already created one demo instance and which is started. Now this is stopped. There is another demo instance which is already running. We can switch on and stop the instances depending on our usage. And that is the benefit we are getting here. If we don't use it, we don't have to pay for it. So right now this is in service. Here I can open either notebook instance, open Jupyter mode, or it is the Jupyter lab mode. So once it is opening, I have already opened a studio because it takes a few minutes. So the studio, once I click on the studio mode, it will show me all the listed users. I am using this fraud detection user here, and then I'll click on the launch app and studio, and then it will open this studio interface. So if I go here, this is the studio interface, SageMaker Studio. In the SageMaker Studio, we can quickly start on any programming or any solution by using SageMaker Jumpstart. Lot of solutions are already provided by AWS to start our machine learning project. We can see here the corporate credit rating prediction, product defect, light GBM classification, then CAT boost regression. There are several other solutions available, and mostly solutions are available from financial services, different industry like healthcare. Then we have the text-based model solution, then computer vision for the vision models, then tabular models, and some of the inbuilt algorithm if we need to take a deep look at it. Here I'm going to open a SageMaker solution, explain credit decision. If I click on it, it will take me to the solution page and it will ask me to launch. This is just a single click launch. If I click on it, it will launch the entire solution. It will take few minutes. So I have already opened that here. Now before that, I want to show you that lab, what I wanted to show you earlier. So this is a typical Jupyter lab interface, what we have seen in your local environment. This is exactly the same. So once you go to the AWS, after that, everything is same the way we work in our local. So that way we don't have to do anything new. And then we can start our new model, or we can start our new notebook, and we can use some of the notebook. We can create any kernel. We can select any kernel from the listed options, and you can see here several kernels options are here. I can just choose a simple conda python 3. It will give me the notebook, and then I can start working on my model. Let's look at the studio. Now, the difference between this notebook outside studio and inside studio, we can create an entire secure and compliant domain by using the VPC subnet and NAT gateway. So this particular domain here, I am using to launch the credit explainable solution. The solution is already launched. Once the solution will be launched, we will be able to see this particular folder is created under S3 download. So here a couple of solutions are launched in my domain. I am going to show you this one, explainable credit decision. So if I double click, it will show me all the folders which are created by the solution. Here you can see all the notebook. So there are total 5 notebooks are created. The zero, this is the first notebook. This is just the introduction. Nothing is there. Let's look at the notebook one. So entire code is already available with us. Here we have used a test data set, synthetic data, which is used from a credit transaction. So what we are going to do here, we are going to check whether a credit transaction is fraudulent and not, and we are going to explain why a particular transaction is predicted as fraud. Thus, notebook one is typically processing the data and loading all the modules here. You can see the modules are generic Python Panda modules, as well as we have loaded the Boto 3, which is used to integrate all the AWS services within SageMaker. Then we have the second notebook where we are using the model training mechanism. This code is available in a GitHub, and you can go and you can download the entire module if you don't want to use this one-click solution. But it's better if you, for the first time, we can just click and entire solution will be deployed in SageMaker Studio. You can see all the data storage is using the S3 bucket here. So this is exactly we are using here. Now here exactly the model is being trained. The estimator is used here. The sklearn light GBM estimator is used. And then we are fitting the model with our trained data. Now all the training data are placed in the S3 bucket. Everything is kind of interacting. Each and every data processing is interacting with the S3 within the code. Once training is done, the model will be created. We can monitor and track everything on the SageMaker interface. So here you can see processing, all the processing jobs. So here like training process. After that, we'll create the clarify job, which will predict the model prediction, which will explain the model prediction. All the clarify jobs, model prediction jobs, everything will be running under this processing jobs. And we can monitor whether they are completed, whether they are failed, whether they are running, something like this. Then comes the training. Once we run the training jobs are created. You can see several training jobs are created as and when I run all the jobs, all the training process. And here also you can see the status, when it was created. If you click on any training job, it will show me the details of that particular training job. Okay, so something is not here. So let's look at one of the, let's say this is one training job. If I click on it, it will tell me when the job was created, what is the ARN, how the job was created, what is the status, and then we can see the other details. So everything is tracked within this interface, and we can also monitor. This monitor is done through the CloudWatch, where CloudWatch can track the progress of any process, and it is generally placed here in a visual interface. Depending on the memory utilization, we can track the disk utilization. If a processing job is running for a longer time, we can see the resource utilization and we can take the necessary action. Hypertuning jobs are also created here separately in a separate window. Then let's look at the inference. Now, inference is something where we are going to create the endpoint. Right now, you see there is no endpoint. But because right now I have not run it yet, I'm not going to run it because it will take a lot of time to create the endpoint. This particular endpoint creation is done through one notebook. Here we can see here model explanation. First of all, this will create the endpoint and then it will run the clarify job to explain the model prediction. And we can visualize the model prediction through a report. How to create the endpoint? Once we run the job, the endpoint will be created and configuration will be saved here. and we can create the endpoint from the configuration later anytime when we need to create that endpoint. So endpoint configuration is here. I'm just going to pick up any configuration. So I'll create endpoint. So here I'm going to endpoint. Let's say the model is already run. After that, endpoint was stopped. Now today I need the model prediction. I'm going to create one endpoint. Let's say credit default, and I have to select which configuration I'm going to use. Let me see if I get that old credit one. I don't see it, but that's fine. So here, so this is the credit default solution. I'm going to use this and apply to endpoint. Oh, okay. So endpoint is still coming up, I guess. Okay, it's not yet created. Then create endpoint. Okay. Now you can see it is in a creating state, and this credit default kind of endpoint will be available after a few minutes, and then we can apply the explainable job to check the prediction which is made by the model can be explained or not. But it will take few minutes. So I have already created an explainable report here. The explanation report is created by AWS Clarify by using the SHAP algorithm. This is a typical explanation report where we can see these are the features which are used to predict the model prediction, and here we are seeing what is the importance of each feature on the prediction. Here, by looking at the length of this particular arrow, we can see the finance underscore account checking balance no account equal to 1 is having the maximum impact on the model prediction. Now, how to read it? Here we are going to predict credit default risk. The score is predicted here 26%. The baseline is 28%. So risk has been reduced from the baseline risk. This is the overall model prediction. Now, baseline risk, the prediction risk prediction has been decreased. Now, let's look at which particular feature is contributing to this particular risk factor. The first one is finance account checking balance. That means, how to read it? That means this particular feature is telling us whether the person has any balance in their finance account. Now, no account, that means the person doesn't have any account, which is true because the value is 1. So that means if the person has no account in their balance account, that means the credit default risk will increase. Because it is 1, it is showing on the left hand side. So when it will be 0, that means when the balance no account is false, that means the person has balance in his account, default risk will be reduced. That is true if we look at it. If somebody has a good amount of money in the balance in the savings account or any account with the bank, default risk will be reduced. On the other side, let's say another one, employment duration is 0. If it will become 1, that means person has employment duration, it's 0 means there is no duration, the person is not working. That will increase the default risk because the arrow is the red arrow which is showing on the right hand side. So that way we can have a fair amount of idea what are the different predictors are having the maximum influence on the prediction. That way we can explain our model well to the business user or other stakeholder. So this is an excellent feature which is given here. Then let's look at that endpoint, what we're trying to create here. Okay, so endpoint, you can see now endpoint is in service. We can see the endpoint here, and the same endpoint can be accessed by any API gateway which is sitting outside the entire cloud environment. So if your consumer application, let's say a banking operation which is deployed in a bank's own data center, and they want to use this predictive credit score from the AWS cloud, that can be done by using AWS API gateway, and it can be done real time as well, because this endpoint is currently running, and real time interface and real time prediction can be done whenever we'll send a customer feature, and I will get the transaction credit score is high or low. So with this machine learning platform, you can see this is also batch transform is also available. Like when we say send a bulk of customer information, we can also get the prediction of the entire batch. So this is an excellent facility which is given by the SageMaker, through which we can achieve excellent advanced machine learning platform in cloud. With this note, I'm going to end my session today. Thank you very much for watching the session.